Hey, general math, going into truth tables today, 3.2. So just like we talked about in 3.1, we have conjunctures, disjunctures, and negations. Let's talk about conjunctures first. So we have P and Q. Remember that intersection sign we had that was kind of an upside down U? Same idea here with the upside down caret, P and Q. So what elements do we have in this statement? We have the letter P and we have the letter Q. So we're going to make a table, and it's just kind of like a T chart with multiple columns. And we have P, so we have a P column, we have a Q column, and then we have a P and Q column. So let's say our first scenario is P is true and Q is true. Well, if P and Q are true, then P and Q is true. And then the second option, we have P is true again, but this time Q is false. So we have a true, false. For conjunctures, they both have to be true for the statement to be true. So since one of them is false, the whole statement is false because it has to be both. It's and, it has to be both. Thirdly, we have false, true. Since both of them are not true, the whole statement is false. And then lastly, we have false, false. So also the whole statement is false. Notice there's going to be kind of a pattern here. We kind of take out all of the options. So like true, 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 false, false, true, false, false. We kind of cover everything. Now we have disjuncture. So we have P or Q. So we're going to write all of our elements, P and Q, and then P or Q. So again, we're going to use the same first two columns. So true, 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 false, false, true, false, false. Well, here, since it's an or, only one of them has to be true for the whole thing to be true. So we have two trues. Obviously, we have one of them that's true. We have one true, one false. We just need one. It's just one or the other. Again, here in the third row, we have one or the other. So we have false, true. That makes the whole thing true. We just need one. But here we have two falses. There's no trues, so the whole statement is false. And then here we have not P. So the only element we have in here is P, and then we have the negation of P. So if P is true, the negation of P is false. And then if P is false, the negation of P is true. So the negation is kind of like a negative sign, and just flips it. Here we have some compounds. We're going to say that P is false, Q is true, and R is false for this statement right here. So we have not P and parentheses Q or not R. So we are going to read this as not false because P is false, and parentheses Q is true, so true or not false because R is false. So not false and true or not false. We're going to look inside the parentheses first. So not false is just a funny way of saying true, right? So it has to be true or true. And then we have not false here again. So not false is true. So not false and true, because if we have true or true, again, if we go back up to here, true or true, the whole thing is true. A lot of trues and falses here. I'm sorry if it's confusing. Zoom me if you need another explanation. So not false is true. So we have true and true. And then if we look at the table up here, true and true, notice we have the conjuncture right here. If it's true and true, yeah, the whole thing must be true. So constructing a truth table. So let's say we have parentheses, not P and Q, parentheses, or not Q. So let's look at what elements we have. We have P, we have Q, and we have Q. So let's start off with P and Q in our columns. Well, we also have not P, and we also have not Q right here. And then we also have not P and Q, so not P and Q. Sorry for the scribbling. And then we have the whole thing. Our last column is always the whole statement. So not P and Q or not Q. So just looking at the first two columns, we have true, true, false, false, true, false, true, false. We're always going to start like that with two elements, just like we saw up top. And then we're going to fill out the columns as we go. So not P, that's just going to be the opposite sign of P. So if this is true, this has got to be false. This is true. This has to be false. This is false. It's true. If it's false, not P is true. All right. Same thing with not Q. We're going to reference the Q column. So if this is true, this is false. This is false. This is true. True, false, false, true. We're just flipping the signs with the negation. Okay. Now we have not P and Q. So remember, the and means that both of the columns, both the not P and the Q column, so we're looking at these two columns right here, they both have to be true for this column to be true. And where is the only place, the only row that Q and not P are both true? That's the third one. So we have true here in the third row, and all the other ones don't have two trues. All right, so now we're putting it all together. So we're using the not P and Q, that's this column, or not Q. So since it's an or, we just need one of these columns, so either this one or this one, to have a true. Since it's an or, it's a disjunction right here. Well, both of these are false, so the whole thing is false. That's a true, so it's true. That's a true, so it's true. And that's a true, so it's true. So remember, when it's an or, you only need one true. When it's an and, you need two trues for the whole thing to be true. All right, kind of back here we have, if you have n components, you will have 2 to the n rows. So since we had 2 components in this example, we had P and Q, we just count one of the Q's, we had P and Q, 2 to the second, because that 2 comes from having 2 components, is going to be 4 rows. So we had 4 rows. That's just kind of how you can self-check yourself. And then lastly, 2 statements are equivalent if their last columns of the truth table are identical. So if there was another statement that had false, true, true, true in its last column, we would say that those 2 statements are equivalent.